Okay, for my first demonstration, I'm going to use the part whole problem type along with our strips of paper, some concrete manipulatives, and then our word problem. This is for grade 2, and it says, Mrs. Butler had a kindergarten class of 24 students. 12 of the students were girls. How many of the students were boys? One thing we need to look at is not keywords, but the numbers and the relationships between each of them. So we know that she has 24 total students. And if we were looking at our strip, we know that this is the whole class. So the total number of students. And then 12 of the students, which would be half, are girls, and the other half are boys. So together, the girls and the boys make the total number of students in the class. For the students that need first the concrete manipulatives, we can use counters and say we know that Mrs. Butler has 12 students that are girls. So we have 1, 2, 3, 4, and I will put this on. And when we count them out, we like to count them either on a 10 frame or similar to a 10 frame like we did in Module 1, because students will better recognize that as subitizing. So they'll see 10 down in a row and automatically know that it's 10. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. We know that she has 24 total students, and so if we have 12, we can just count to 24. So we know we have 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, and 24. So going back, we know the purple hearts were the girls, and we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 girls. So to see how many boys we have, we can count the red ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So there's equal number of girls and boys, 12 girls to 12 boys. Now if we're looking at this on the set model, we can see that the whole number, this whole thing, is the total number of students. And we can say part A, since we know, is girls, and part B is boys. And so we'll put a 12 here for girls. The whole number of students is 24, and then we don't know how many boys there are. So part A right here in the algebra part would be 12 plus question mark, because we don't know, equals 24. One important thing to teach students is the relationship between the left side of the equal sign to the right side of the equal sign. They have to be the same or equal. That's why this set model looks like a balance. It has to be balanced out. So if we wrote it out like this, plus, we'll put a B for boys, equals 24. We have to subtract 12 from each side. So the total number of boys equals 4 minus 2 is 2. And then 2 minus 1 is 1. So the number of boys equals 12. And to go back and reiterate, the reason that we subtract 12 from both sides is because both sides of the equal sign have to be equal. So if we subtract 12 from the left side, we have to subtract 12 from the right side. For the second part of my demonstration, this is also for a second grade level, and this is going to be a separate problem. So we'll go ahead and read it. It says, Nikki earned $30 for doing her monthly chores. She then bought a movie ticket for $9. How much money does she have left? So again, not looking at keywords, but looking at what's important in the problem. is Nikki has $30. So we know that's what she has for doing her chores. She then bought a movie ticket for $9. That means that she spent the money and no longer has it. And that's why we know we need to use separate to separate the $9 from the $30. We can look at the strip diagram again and see the blue strip is the total number of dollars that Nikki earned when she did her chores this month, which is 30. So this will be the total number of money or dollars. And then she spent $9. So this strip shows how much money she spent, got rid of, and that we need to take away. If we look at our linear model, and we see that the start, or the amount of money that she was given or started with, was 30. One common misconception that students might do is write the 30, the number, inside the box, and that's incorrect. It actually means area. So if I wrote 30 in here, that means that the area is 30, not the total number of amounts. So that's a misconception to tell students to make sure that they understand what the difference is between writing it up here and in the box. So we know she starts with $30. And the change, or what she spent or what she got rid of, was $9. And we see the change arrow going this way because we're going to take it away from the total, and this line, or this half of the line, is what is going to be left. So if we come down here to our equation, or the algebra part, it's 30 minus 9 equals the result, which we don't know. So let's write it out how a student would be able to do it. 30 minus 9. So 0 minus 9, we can't do that, so we have to regroup the 3, and so we take away one 10, and we have two 10s there, but we move the 10 over here, as in we're regrouping. So we have two 10s, and then 10 minus 9 equals 1, and then two 10s minus 0 10s equals 2. We again got the number 21. If we want to recheck our work, we can say 21 plus the $9 that she spent. And we see 9 plus 1 is 10, so put the 0. Regroup the 10s over to the tens place. 2 10s plus 1 10s equals 30. So we added what she spent to what she had left to see that she actually started with 30, and we know that our answer is correct.